exponential function has the form y equal a times b to the x. A lot of students mistaken exponential function with quadratic or polynomial. What's the difference between the polynomial and the function in this form? You see the variable is on what? It's on the power, right? It's in the power, right? Where polynomial, the variable is in the base, right? X squared, x cubed. Here we have 2 to the x, right? It's kind of flipping around, right? So of course, in terms of graphing, this function grows much faster than polynomial. Where b has to be positive, b cannot be negative, and b cannot be 1. So the number line, if I have a number line from negative infinity to positive infinity, and then I have 0 here, I have 1 here. B cannot be negative. That means I'm scratching out that part, right? Only from between 0 and 1, not including 1, so hollow dotted 1. So we have 2 cases here. One case is where your base is between 0 and 1, like 1/2, 1/3, 1/5, 1/10. And if b fall into that case between 0 and 1, then your function called exponential decay is decaying. It's decreasing. Let me highlight it in red. So this part is exponential decay, which we're going to learn later. I'm going to give you a heads up. Okay. And then if b is between 1 and infinity, between greater than 1, like 2 to the x, 3 to the x, 5 to the x, 100 to the x, then you have a case called exponential growth. Example will be bacteria growth. That's how they grow exponentially. Your investment, retirement investment, if you haven't already. I know you're young, like, what would I think about my retirement? Trust me, you should. Because you gotta have the time. Time is everything. Maybe I'll show you a video how retirement investment grow. Okay. Let's evaluate them first. Let's evaluate the exponential function. I have f of x equal 5 times 4 to the x, where x equal to 2. So now f of 2, right? I want f of 2 equal 5 times 4 to the second. Order of operation. Do you take 5 times the 4 first, or you're going to square the 4 first? Yeah, you square first, right? So 14 times 5. Let me write out loud. 5 times 16. Did I say 14? I'm sorry. I'm still thinking about it. Let's see. Incident. 5 times 16 is 80. Where 1b, I still evaluating x, but it's slightly different. Evaluate x equal to, here quantity of 5 times 4 raised to the x power, or raised to the second here in this case, bless you. Now we're gonna, now there's many ways of doing this. You can distribute the 2, so 5 squared times 16, right? Or you can multiply inside the parentheses first. It will give you the same answer. Let's multiply inside the parentheses first. So the 20 to the second, that's 400. Or you can do like this. You can distribute the square, right? Remember the rule, recall. If I have a times b to the n, I can distribute a to the n times b to the n. 5 squared is 25 times 16, which is also 400. Either way, as long as you use the correct rule. Let's finish them all. Evaluate f of x where x equals -3. F of -3. So this is equal to 2 to the -3. What 2 to the -3 equal to? Instead of 2, I'm going to write it 2 over 1. Is that okay? 2 over 1. Maybe I use run out of color to use. And then what do? You want to get rid of the negative exponent, what do? You flip, right? You flip. So be 1 over 2 now becomes what? +3, right? There's a rule. Let me recall again. If I have a over b to the -n, I want to get rid of the negative exponents. All I do is just flip in the fraction inside. So b over a now is positive to the n power, which is 1 over 2 cubed, right? 1 cube is still 1. 2 cubed is 8. Do you guys remember those rules? Long times ago. Let's keep doing. Let's keep finish them all. Is 1/2 to the -3 now, using the same rule. So it becomes what? You want to get rid of the negative exponents, you flip, right? So 2 over 1, right? Now it's positive exponents, +2. 2 cubed is 8, 1 cubed is still 1. So a over 1 is the same thing as 8. Oh, by the way, I found a graphing calculator in this class. If it's yours, let me know. Let's be honest about it. This calculator pretty specific. If not yours, so I'll send out emails. Michael was not here. F of -2. 18 times 3 to the -2. What should I write next? Do I multiply the 18 by the 3 first, or do I take care of the 3 to the -2 first? No, you don't do that, right? Those are two different things. You have to convert to the same thing before you multiply them together, right? 18 and 3 to the -2 are different things. So you cannot combine them together right now, not now. So let's take care of the 3 to the -2 first. So we write 18 times what? 1 over 3 square, right? 1 over 3 square. 1 over 3 square is something is 1 over 9. So 2. I want you to use a calculator to evaluate number 4. It seems easy, but people make mistake on the exam. Number 4, the reason I'm making you doing this because later you're going to have a application of exponential function. You're calculating the bank balance. So it comes in this form. It's very easy to make mistake. I don't know how good your calculator can do. I know it's not as good as graphic calculator, but can it do like multiple operation at the same time? Yeah, okay. Make sure you put parentheses in us. For example, if you take 1 plus 0.043 divided by 4, if you cannot write it in fraction form, put the parentheses around the quotient. Okay. What you get? Someone tell me what you get. Say it again. Okay, good, good. Is everybody got the same thing? All right, good. Make sure you get it right, because on the exam, you have something like this. It's in story problem form, of course, but it's just baby step. Always route it to the 2 decimal places, because like I said, this is a money problem. Route it to the nearest cent. So 19 cents. So far, so good. Just easy stuff. All right, let's practicing how to write to a certain base. Right? For example, usually I don't like the way it wrote like this, 1/2 to the x. Right? Usually, especially in this class or any really class really, when we saw exponential function, we usually write it into say 2 to the something, right? Instead of 1/2. Mostly. So I want to change it into base 2. What would I do? What would I do? The 1/2 become what? Well, the 2, right? I want base 2, so 2. But when I do it like that, what happened? I mean, I'm flipping, right? So x becomes negative x. Well, 2 over 1 is the same thing as 2, so 2 to the negative x. This implies 2 to the negative x equal to 1/2 to the x. So don't write this down. If I wrote things like this, you understood as what? The base between 0 and 1, right? 1/3. If I write like this, same thing, right? If you have a negative exponents, your base is between 0 and 1. Because you're flipping it. Part B, and I want to combine 1/8 and that number 2 to the x. So I need to convert the 1/8 into base 2. Let's do it slowly. 1/8. 1/8 is the same thing as, you know what, here. 1/8 is the same thing as 1 over 2 cubed. You agree? 1 over 2 cubed is the same thing as 1/2 all of that cube, yes. And we need to convert 1/2 into base 2, so 2 to the negative 3. Or 2 over 1, the same thing as 2 to the negative 3. Times 2 to the x. So this equal 2 to the negative 3 times 2 to the x. Can I combine these two together? If I have a to the n times a to the n equal to a to the n plus n, right? So equal to 2 to the negative 3 plus x, or I like to put x before, so 2 to the x minus 3. Be careful, be careful. A to the m times a to the n is different than a to the m to the power n. Here in this case, you multiply the power together. Right. So notice that when you have two of the bases are same, you add the exponents. If you have one base and you have two exponents on top, you multiply the exponents. So be careful. just a long lecture too. Oh. All right, graph. How do I graph the exponential function? Well, if I ask you to graph something, the first thing you do is making a table. Everybody can do that. So here they make a table for us here, which is good. They put in some value for x from -3, -2, -1, 0, 1, 2, 3, and then plug in for x. So when I have x is -3, 2 to the -3 is the same thing as 1/2 to the third, which is the same thing as 1/8, and so on and so forth. I don't have to go through all of that. You have the calculator to do that if you don't like. Let's graph this. The point is, let's graph this. When x equal -3, y is 1/8. I mean, it's really, really close to the x-axis. It's really close to everything. It's a tiny little dot there. When x is -2, y is 1/4. When x is -1, y is 1/2. When x is 0, y is 1. I'm going to put this in a block dot. It's important. Remember that. 0, 1. This one right here. That's what we're going to use for translation, which is later. When x is 1, y is 2. 1, 2. When x is 2, y is 4. X is 3, y is 8. Make it a little more prominent. Whatever you do, do not cross the x-axis. I know it looks like I'm touching it, but in reality, I shouldn't be touching it. Because why? Because the x-axis or y equals 0 is your horizontal asymptote. Right? Remember, what's the characteristic of horizontal asymptote? When x approaches -infinity or positive infinity, your y value approaches 0, right? It approaches a certain value. Right? Get close to it, never quite touch it. So as you can see, when my base, remember this is the graph of y equal 2 to the x. The base is bigger than 1. What do you see from left to right? It's increasing, right? We call that exponential growth. Remember I said that in the beginning? Right, so it's increasing graph from left to right. We call that exponential growth. The example will be retirement money, material growth. Right? Maybe I'll show you something. See if I can show you something. Yes. Sure. One of my colleagues showed me this. I thought it's kind of cool. How come I can't hear? Oh. 2 weeks.
We ask people a question. How much money do you have in your pocket right now? That's $40. 53. Do you think the money in your pocket could make an impact on something as big as your retirement? Yes. It's hard to imagine how something so small can help with something so big. But if you start putting that towards your retirement every week, let it grow over time, for 20, 30 years, that retirement challenge not seem so big after all.
See how, what is the power? See how the power of the exponential growth. The moral of the story is get the retirement in early. right? Because you can have the time, right? This is a long-term thing. He talked about 20 years, 30 years, right? Your money make interest, and that interest keep making interest on interest. Right? So that's why the exponential function grows so fast, so quick at a certain point, right? As you can see, when you start out, it's kind of flat, right? But at a certain point, it just kind of goes really steep. Right? Sure. So right there, that's a curve. It started out really, really kind of chill, right? Kind of hovering above the x-axis. But at a certain point, it goes really fast, really quick. You guys heard of viral video? Right? What's viral video mean when they say viral video on YouTube? It means it has a lot of views, right? So overnight, it's all of a sudden the number of views like go really fast, shoot up to very high. On the other note, we have exponential decay. Right? So same thing, I'm going to plug in some value. Now my graph is y equal 1/2 to the x. So this graph is your base, which is b. When I say b base, I meant b. In between 0 and 1. Right? 1/2 between 0 and 1. Logistic is a it is logistic and exponential. They kind of relate to each other. Logistic, it looks like this. Don't copy this down. So it started out like an exponential function, but at a certain point, it's level off. So that's logistic. Kind of like population growth. At some point, well, right now we grow exponentially, right? But at some point, the population has to level out because we don't have enough resource to take care of everybody, right? At some point, people are gonna die off, right? If they run out of resource, so it's level off, right? One way or another. So that's called logistic growth, exponential growth without bound, right? No bound. I hope it's right. You're welcome. Let's graph this one. When x equal -3, so it's like backward. Now when x is negative number, the y is big. Right? Remember, we have to choose the -3, -3, right? So become +3. -3, 8. So start up here. -2, 4. -1, 2. 0, 1. So again, that's the important point. 1 is half. 2 is a quarter, and 3 is 8. Again, do not cross the x-axis. You can touch it, but don't cross it. So here you see a decreasing function, decreasing graph, and we call this exponential decay. Example will be radioactive, decaying over time. That's their function at a certain point. So start out at 100 grams, maybe a few thousand years. They kind of be slow. At first, they decay really fast. Why? Because they have a lot of material, right? A lot of material that help the reaction go fast, right? But as the amount decreasing, they have less stuff. They decay a little slower. Right? But at some point, it's gonna disappear. Nothing lasts forever. Yes. So remember, when you have b is bigger than 1, your base bigger than 1, you have increasing graph, exponential growth. When b between 0 and 1, you have exponential decay, decreasing graph. And the point, they always go through 0, 1, at least for the basic graph, right, for the parent graph. Of course, later you're going to shift. You're going to shift left, shift right, shift up, shift down, flip it, left and right. Then it changed, but you always start out with 0, 1, and then you go from there. Let's talk about the domain and range of the exponential function. What is the domain if you look at it? Not domain. Where does the graph start? Where does it end? No. Everything, right? Everything. Right? It's everything, right? It start from negative infinity, and of course that thing going forever. It get stretching out a little bit, one at a time. So overall, it's everything. So negative infinity to positive infinity, and it's always like that, even shifting graph. What about the range? Where does it start? I go below 1. 0, right? It just, do I include 0? Remember, 0 is your horizontal asymptote. What does that mean? You don't touch it, right? Unless you told so, but in this case, it doesn't touch, right? So you hover above 0, so you start 0, you don't touch it, so we use parentheses, and it shoot up to infinity. Remember what I said in the beginning? Right there, right? That's the range, right? From 0 to infinity, minus the 1. The x-intercept will be, is there an x-intercept? No, so we say does not exist, D and E. Y-intercept, yeah, 0, 1. And it's always 0, 1 for the parent graph, for the basic graph like that. Do we have a vertical asymptote? No, right, so does not exist. What about the horizontal asymptote? Yeah, y equal, very good, y equals 0. And I'll tell you where can you find the horizontal asymptote without looking at the graph. The exponential function in the ultimate form, it has this form. You may want to write it down. Maybe I'll use green. Y equal a times b to the x minus h plus k. Remember that? I kind of like quadratic, you have minus h and plus k. It's the same thing here, right? Where minus h, where the h tell you to move horizontally, right? And the k tell you to move up or down, and the a tell you to flip over the x-axis or not. Right? If it's negative on the x, then you flip over the y-axis. Remember that? Or in this case, the k. So the horizontal asymptote is come from the k. That's your horizontal asymptote. So y equal k. This one I can rewrite it as what? I can rewrite it as 2 to the x minus 0. Well, 1 times 2 to the x minus 0 plus 0, right? So this, in this case, my horizontal asymptote will be y equals 0. How's the graph g of x, which is 1/2 to the x, relate to the graph f of x equal 2 to the x? They both go through 0, 1, right? Oh, welcome. Please. No. happened last time in one of my classes. I hope I joined the class early. One more time. It's the internet. Yay. Yes. All right, objective 3. Find the equation of an exponential function given 2 points. Part, is there a, no, not yet. Not you try yet. Part A, 7A, I'm not gonna go through it. You can read it yourself, right? But I'm gonna give you an example. Actually, I have to, because they have a part B. Oh, never mind, I have to. All right, given the 2 points, say 5, 4 and 3, 1. I want to find the equation of the exponential function. So let's use 1 point at a time. So I'm going to substitute 5, 4 into this equation right here. Like that's original, that's general standard form, however you want to say it. Then I have y is 4, right? So 4 equal a times b to the x, which is to the 5th. So far, so good. And I do the same thing for the second point. Substitute that into this equation again. Now I have 1 equal a times b to the 3rd. Now I have 2 equations with 2 variables here, a and b, which I need to solve for. The next step, you're gonna take quotient of those 2 equations. You divide them. So take the first equation divided by the second equation, side by side. So 4 divided by 1, and then a times b to the 5th divided by a times b to the 3rd. 4 divided by 1 is 4. On the right-hand side, the a and the a cancel, yeah. And then b to the 5th, and then b to the 3rd. They cancel 3 of the b's. So how many left? Yeah, b squared left, right there. So now I have 4 equal b squared. I'm gonna solve for b, so I'm gonna take square root both sides. When you take square root, you have plus and minus. So b equal either positive 2 or b equal negative 2. And because the definition of the exponential function say what? B cannot be negative, right? So we cross that second option out. Do it like that. So b equal 2. Once you have b equal 2, you plug it back into one of the equations above. It doesn't matter which one. Pick something that's simpler. I think in this case, they pick the second equation. It looks simpler. And then you solve for a. At the end, you rewrite the whole function, which is your answer, like that. Y equal a times b to the x. A is 1, 8, b is 2. Now, how do I know that I got the right equation? Well, you can check. You can check. So remember, you have, in the beginning, you have 4 equal a times b to the 5th, right? A is 1, 8. B is 2. 2 to the 5th is 32. What 32 divided by 8? 4. Right, so it check. And then you check for the second one. 1 is equal to 1, 8 times b cubed. B is 2, so 2 cubed. What 2 cubed equal? 8, right? So 8 divided by 8 is 1, which is equal to the left-hand side, which is check. Right? So we know that your equation is right. That one is correct. So far, so good. The equation found in part A, they're talking about this one right here. That one right there. It took a long time to appear. The equation found in part A is vertical compression of the graph y equal 2 to the x. Is it true? Yes, right? It's compressed. It compressed because the value A is between 0 and 1, right? Remember vertical stretch and vertical compression. Can you write the equation y equal 1/8 times 2 to the x as the Hanazano's translation? What do they mean by that? Hanazano's translation, remember I gave you the form earlier? Y equal A times 2, B to the x minus A plus K. That's what they meant by Hanazano translation. They meant this. They meant that part, right? Hanazano translation. So can I write 2 to the x minus something or x plus something? We did this before, do you guys remember? In objective, I think the first page, right here, this one. 5B, we did this before. So I'm not gonna do it again. So yes, we can, right? We turn it into 2 to the x minus 3. That is your horizontal translation. So you say yes, since y equal 1/8 times 2 to the x, we can rewrite it as 2 to the x minus 3 from part 5b. This one gonna shift to the right or left? Yeah, right. Shift to the right 3 units. Number 8 is your U try. Or you find the equation. All right, move on to the next part is application. It's the same thing with the commercial you watched earlier. That's how money grows. That's the formula. You put some money in the bank, that is the formula. So I have the formula A of T. A is your balance, your current balance. P is stand for principal, how much you put in the beginning. R is the rate in percentage. Of course, when you plug into a formula, you should change it into decimal. Let me highlight what I'm talking about. So P is principal. A is your balance. R is the annual interest rate. Usually we express in decimal. T is the number of year of investment, say 10 years, 20 years, 30 years, sometimes 5 years. K is the number of time per year the interest is compounded. If I say yearly, you compound once a year, right? Semi-annually will be twice a year. Right? Quarterly will be 4 times a year. Monthly will be 12. Daily will be 365. You're supposed to know those. Let's do number 9. A total of 5,000 was invested in a college fund. So 5,000 will be what letter here? Yeah, your principal, right? I'm sure your parents do this to you, for you. They have a college fund that they put in slowly when you was little, right? When you come of age, you can take it out. If you spend that money on college, then you don't have to pay tax. If you don't have to pay tax. So 5,000 is my principal, which is 5,000. 1 plus rate is will be what? Which is in decimal. Very good, 0.043, right? Divided by K will be compound quarterly, so K is quarterly. How many times a year? 4, right? We got 2 pilots. No problem. That's all right. It's just kind of cute when you say that. K times T. The exponent K is 4. T, how many year? 15 years. We did this before in the first page. That's why I told you to do it. Remember this one? That one. Good. So $9,497.19. 9,497.19. I forgot the number. What was it? So after 15 years, they from 5,000, they roughly add another 4,500 to your account. Not much, but you know, anything helps. Usually for these account, they are conservative investment, right? Because they want to guarantee you have some kind of money at the end. Money grows slow, but it's safer as opposed to, you know, invest in stock, like dangerous stocks. Some people do day trading. They can make a lot of money in a short amount of time, but it's also very dangerous. Number 10. So you guys okay with this? Now, what happened if you forgot to change the decimal, the rate into decimal? Then you can have you're gonna have like millions of dollars at the end, which doesn't make any sense, right? If I can do that, I wouldn't be here teaching. And if you know a bank that can take that much of the rate, let me know. I'll give you a name in the class. All right, number 10. Find the initial deposit of an account that worth $14,472.74. So this number represents what letter here? Is it your balance or principal? That's your balance, right? So A is your balance. Let me rewrite the formula. It's a good habit. By the way, you don't need to remember this. It will be given on the exam. So 14,472 and then 74 cents, that's your balance. The principal is what we're looking for, the initial deposit. My rate in decimal, yeah, 0.055. My K, number of compound. Number of compound. Yeah, compound monthly, so 12. And then KT, so K is 12. How many years here? 5 years. Right. I don't have this. Oh, let's do this one step at a time. I write so large. Let me move it to the left a little bit. I'll show you how I calculate this without making a lot of mistakes. First, I'm gonna calculate the inside the parenthesis first. So 1 plus 0.055 divided by 12. 1 plus parenthesis 0.055 divided by 12. Close parenthesis. I have roughly 1.3157, etc. Right? Just you can get as many decimal places you're comfortable to. Go. Put the P down. And the amount rate to the 12 times 5 is 60. Equal $14,472.74. And then you take that blue one, 1.3157 raised to the 60 powers. What do you have? Did I make a mistake for something? No. 1.3157 raised to the 60 power. Okay, something wrong. Did I make this? 1 plus point, oh, what did I do? Divided by 12. Okay, I got it wrong. Hold on. Sorry, yeah, thank you. So this is 1.0 something, right? Oh, is that what you got? 5, 8, is that what you got? Okay, thank you. And then raise to the 60 power. So I got 1.3. I was ahead of myself. 1.315, etc. times P equal that thing again. And now I divide both side by, yeah, that 1.157. So P equal 14,472.74 divided by 1.3157. So my principal was 11,000. Round to the nearest cent, 3 cents. And it's US dollars, so we're gonna put that. On the exam, if you have something like this, it's likely you're gonna have problem like number 10 instead of number 9. So far so good. So exponential function, there are 2 cases, if you remember. Decaying where b between 0 and 1, grow when b is greater than 1. And then the formula right there, you don't have to remember. It'll be given to you on the exam. Of course, you have to know where to use it. Right? We don't tell you use this formula for this problem, right? We just give it to you, but you gotta know how and when to use it. All right, next we're gonna talk about a very special exponential function. It's called a natural exponential function. Why is it special? Because the base is gonna be, is b, but it's special because the base is a transcendental number. What is transcendental number? Pi is a transcendental number. It's kind of go on forever without pattern. Like pi, what is the definition of pi? Don't write this down. If I ask you to define pi, you would say, no, that's approximation. You would say it's the ratio between the circumference of a circle and its diameter, right? Because you have what? C equal 2 pi r. You want to solve for pi, divide both sides by 2r. Don't write this down, it's not on your exam. So if I would ask you what's pi, if you're a math person, you would say that circumference of any circle divided by its diameter. But if you engineer people, you say 3.1415 something. Right? All right, same thing with pi. E is the transcendental number and it has its own formula. Let me come up with a formula for you. What I'm going to do next is I'm going to erase this. You don't erase it. Just watch me explaining this. Don't write this down. It's not on your exam. Your exam, you're supposed to use the formula, not explaining it. So I start out with let n equal the quotient between the number of compounding divided by r rate. If I multiply both sides by r, what do I have? nr equal k, right? nr equal k. Now, let me write this in red. Actually, nr equal k in red. In red. Now I have the formula A equal that one we've been using. P times 1 plus R over K to the KT. I'm going to replace K with NR. So this is equal P times 1 plus R over K to the NR T. And I'm going to rewrite it a little bit more, which is equal to P times 1 plus R over K to the N, and all of that to the RT. So far so good, it's the same thing, right? I just kind of put them in different order. N times R times T, now N is here, and the outside exponents, same rule, you can multiply them back, same thing, right? And the formula right here, let me highlight in green, this formula right here, that is your E formula. It's kind of like pi, it has its own formula. So that's where E equal, which is this one right here. That's your E. The green thing, that's your E. And let me tell you why is the E. If I let n equal 1, 1 plus 1 over 1 to the first power is 2, right? If I let n equal 2, 2.25. If I let n equal 4, 2.4416. Let me calculate the difference between this one and this one will be what? Roughly a quarter, right? The difference to the next pair will be 0.19. And then the difference of the next pair will be 0.17. What do you see? The difference is what? It's getting smaller and smaller, right? To the point that when you put n into the very, very big number, the change from 2.6 to what? 2.7 is really small, right? It doesn't change much. If you let n go to infinity, it's still in this number, 2.718 something, right? So it's approach to a certain number, and that number is 2.718282, etc. Right? And that E. So it's kind of like pi, right? It's go on forever without pattern. So that's your E. Right now you understand E. What I'm going to do next is I'm going to replace the green thing, the green blob with E. So what do you have? When you replace it, what do you have? P equal E to the RT, PERT. Okay. So there's another formula. You have this formula, the long one, the one I circled in black. They call compounding formula. And you have the second formula, I'll say circle in red, is the continuously compound. Right? So on the exam, if you say compound quarterly, compound monthly, compound yearly, you use the big formula, right? If you hear compound continuously, you use PERT. And of course, we give it to you, you gotta know when to use it. So that's another formula right there for you, PERT. Right, let's use the two formula to see which one give me a better yield. Oh, by the way, let's talk before we do that. E is 2.7, roughly 2.72. So the base is what? The base is bigger than 1, right? So if you have e to the something power, it represent a exponential growth. So you can see the picture there. The black one is e to the x, and the dash one is 2 to the x. It grows slightly faster because e is 2.7, right? And here the base is only 2 for the dash one. All right, let's take a look at number 12. I have two choices. Either I can invest 5,000 for 15 years at the rate 4.225 and a compound continuously, or I can invest the same amount of money, same year, the rate is slightly higher, 4.3, but I compound quarterly. Compound quarterly mean they refresh your they calculate your balance 4 times a year. Continuously mean what? They keep hitting that enter button. Right? It keeps refreshing your balance. Let's see which one give you better money. So for the first one, I use what? You PERT, right? You PERT because continuously is PERT. And then for the second one, I use the long one. All right, let's see which one give me better balance. PERT is 5,000. Don't replace E with 2.7. Just put E in there. You guys have E in your calculator. The rate is 0.0425 times T is 15 years, and then the other one is 5,000. 1 plus 0.043 divided by 4, right? Quarterly, and 4 times 15. And 425 times 15. I got 9,000. The left one, I have 9,458 and 73 cents. And then for the right one, 5,001 plus 0.043 divided by 4. Way to the 4 times 15. $9,497 times 19. I'm sorry, 0.19. So which one give you better balance? Quarterly, right? Continuously is have its own advantage, but what account for is what? Is the rate, right? Remember the rate is for compound quarterly is slightly higher. The rate is really important. The rate is really important. Good God. Let me see if I can ask Sarah. Is that okay? I asked Sarah to explain it to you in class, in the workshop. I'll ask Sarah to do objective, the last objective. Hang on, let me give you the second you try. 13B. And I'll ask Sarah to explain the rest. And I'm gonna post the complete notes on Moodle as well.